Hello everyone, how are you all? I hope you all are doing very good. In the last class, we studied completely about plane mirror, like basics of plane mirror and reflection we studied, ray diagram of image formation by plane mirror with measurements we studied, and characteristics of image formed by plane mirror, angle of deviation, introduction, derivation of formula for angle of deviation, and how the angle of deviation varies with angle of incidence, and problems on angle of deviation, and what is the focal length of plane mirror, what is the power of plane mirror, and why is image distance is equal to object distance in plane mirror, and is sign convention applicable for plane mirror or not, and what is the magnification of the image produced by plane mirror. These all things we studied in the last class. In today's class, what we are going to study, reflection on spherical mirrors with a reason, and image formation in concave mirror and convex mirror, and how to draw the ray diagrams perfectly with measurements of the image formation of concave mirror and convex mirror. These are things we are going to study in today's class, right? So without any delay, let us start the class, right? So we know that when a light ray passes parallel to principal axis in any spherical mirror, reflected light ray will pass through the focus. Correct? But why does it pass like that? Why is it so? Do we know the reason? Let us find the reason for that now. To understand that and to find the reason, you should be knowing that the laws of reflection are applicable in plane mirror and spherical mirror also. Keep this in mind. Laws of reflection. This is very important point which students will live in between. So this you must keep in mind. Laws of reflection are same for plane mirror and spherical mirror also. For plane mirror and spherical mirror. What are those laws of reflection? First law will be the reflected ray, incident ray and normal lies on the same plane, and second law will be angle I will be is equal to angle R. Correct? So now remember this law. Angle I will be is equal to angle R. What is angle I? Angle I will be angle of incidence. Angle R will be angle of reflection. Right? So now let us take a spherical mirror, a concave mirror I have taken, and for that if a light ray passes parallel to principal axis, see I am taking a light ray parallel to principal axis, right? See here I have taken a light ray parallel to principal axis. What happened here? There is a spherical mirror and upon that incident light ray came. If this is to be drawn on a plane mirror, what happens? A plane mirror will be there, and upon the plane mirror an incident light ray came like this. Correct? So how will we draw the reflected light ray for this case? We will first identify the point of incidence and we will draw the normal here. Correct? After drawing normal, we will identify the angle of incidence. See, I am placing the protractor here. Along the normal, I placed the 90 degrees. See, this is the normal, right? This is the normal, and along the normal, I placed the 90 degrees line. Perfectly along the normal, I placed 90 degrees line. So now this is the angle of incidence, correct? What is it here? It is around 42 degrees, correct? You come here. From here 42 degrees. So you come from here. So from here 42, 40, 41, 42. Somewhere here. Correct? So like this we can draw the reflected light ray. If we extend, it will look like the same only. See, This one will be the angle of incidence and this one will be the angle of reflection. Okay, and this one will be the reflected light ray. Now the same thing you apply here also. Incident light ray came. This is the point of incidence. To draw normal, we can draw a straight line from center of curvature. From center of curvature to the point of incidence, if we draw an imaginary line, that line will be working as a normal for us. Correct? So this is a normal for us now. Okay. Now you keep this along the 90 degrees now. This is the normal for us right now. This is the normal for us. So I am going to keep the 90 degrees line along the normal. I kept the 90 degrees line. See, this is the 90 degrees line and I kept along the normal. Now you verify what is the angle of incidence. Angle of incidence is this angle. Correct? How much is this? Around very close to 80 degrees. Correct? Here is 80 degrees. A bit lesser to 80 degrees. 80 degrees is here. A bit lesser. You mark the point here. Correct? You mark that point and you join the line. See, the reflected light ray has passed exactly through the focus. This was the angle of incidence, correct? We measured the angle of incidence and it was around 82 degrees, and with the same angle of reflection we drew the reflected light ray. What happened now? The reflected light ray has passed through the focus. So the incident light ray, when it passes parallel to principal axis, the reflected light ray will pass through the focus is not a rule. It is happening like that because it have to follow the laws of reflection, because laws of reflection are valid on plane mirror and spherical mirror also. So let us take what happens on convex mirror now. Okay, first let us take a light ray parallel to principal axis. Say I am going to take a light ray parallel to principal axis. Okay, so this one will be the incident light ray. What happened now? I'll explain here. See, there is a mirror and on that mirror a light ray came. Until here happened now. This is the point of incidence and this is the point of incidence. Correct? So for this point of incidence we have to draw a normal like this. First, for here also draw normal. From center of curvature to the point of incidence exactly draw normal now. Normal. Let us extend the normal so that we can identify the angle neatly. Okay. So now we have to measure the angle of incidence. How did we measure angle of incidence here? We measured angle of incidence like this. See, I placed the 90 degrees line along the normal exactly and I measured this angle. Here this line is here, means around from here to here. 90, 62 it may be, around 28 degrees. From here, again you go like this, 120. See how to measure. If you are coming in this direction, around 120 lesser. Coming in this direction, here is 120, a bit lesser to 120, like this. Okay. So now that one will be the point. You can draw the reflected light ray like this. Here also you measure in the same way. This is the normal here, correct? So now measure the angle of incidence here. This light ray is there, right? This is the normal here, correct? We want this angle now. This one will be the angle of incidence now. This is the angle of incidence. We have to draw the same angle of reflection now, correct? So I have placed the 90 degrees line along the normal perfectly. I placed. Correct? Huh? So see the incident light, it is passing exactly through 80 degrees, means 10 degrees it came like this. You also come 10 degrees like this. See here, this is the normal line and incident light ray is here. It is passing along the 80 degrees. So 80 degrees is here. You place a point here. because this angle should be equal to this angle, correct? I placed a point there, and now I am going to extend this light ray. See, you can see the focus has already touched. Yes or no? So, when incident light ray passes parallel to principal axis, the reflected light ray will pass through the focus, because here the laws of reflection needs to be followed. Okay, here laws of reflection needs to be followed. This is the first rule. Now, what is the second rule? The second rule, it will be here itself. If in the same rule, if the incident light ray passes through focus, the reflected light ray will pass parallel to principal axis. If this goes like this, if this is the incident light ray, it goes like this. If incident light ray is going like this angle will become angle of incidence, and this angle will become angle of reflection. So when it goes, it comes like this. When it comes back, it goes like this. Either it may be a concave or it may be a convex mirror. This one will be same, applicable to both. So next, if the incident light ray passes through the center of curvature, this is the center of curvature, and it is passing like this. Okay, na? Incident light ray is passing like this. Means what is the angle of incidence here? Angle of incidence will be 0 degrees. Which case in plane mirror this case is? If this is a plane mirror, incident light ray coming like this. See, incident light ray coming like this. What is the angle of incidence here? 0 degrees. So what will be angle of reflection? Angle of reflection will be equal to 0 degrees. So reflected light ray will go in the same path. The same way, incident light ray came like this. Angle of incidence is 0. As angle of incidence is 0, angle of reflection also will be equal to 0. So the reflected light ray also will go back in the same direction. Okay, na? Now coming to convex mirror. So here, this is the center of curvature. From here, light ray came like this. It is appearing that it is passing through the center of curvature. So here also the same thing. Angle of incidence will be equal to 0 degrees. Angle of incidence I is equal to 0 degrees, and angle of reflection also will be 0 degrees. So the reflected light ray also will go back in the same direction. Okay, because it is passing through the normal. It will be passing through the normal. So last case, this case will be when incident light ray makes an angle obliquely with pole. Correct? Suppose this is the incident angle of incidence I. Okay. So now with the same angle of reflection, it should go back. This line itself which is present here, it will be working as normal. Correct? So if this itself working as a normal, then angle of reflection we can measure like this. Correct? See now. See, perfectly it is passing through 70 degrees. Correct? From here also, where is 70 degrees? This is a 70 degrees line. Correct? So the reflected light ray will pass like this, because angle of incidence should be equal to angle of reflection. So third rule of image formation, or third rule, it will be when incident light ray makes obliquely angle with the pole, reflected light ray will also make the same angle with the pole. Okay, right? So now in the same way, for convex mirror also, when incident light ray passes making obliquely an angle with the pole, what happens? The same angle the reflected light ray will also make, and it will pass through the same angle. How much angle the incident light ray made, reflected light ray also will make the same angle. Let us measure this angle first. After measuring this angle, we can draw the reflected light ray. See, I'll try to measure this angle first of all. I'll try to place the protractor the 90 degrees exactly upon the normal. Then we can find out the angle made. See, this is the normal, correct? Exactly upon the normal I place the 90 degrees line. See, correct? So now see here, from here 10, 20, around 22 degrees, correct? And from here again you come back now, 10, 20, around 22 degrees, correct? 70 is the 20 degrees, 21, 22, around here. This is the point, correct? So now this one will be the reflected light ray. This one will be the angle of reflection. This is the angle of incidence and this is the angle of reflection. So I think now you understood how to draw the rays, how to draw the reflected light ray for any incident light ray given on concave mirror and convex mirror. Now let us try to draw the ray diagram of image formation. Okay, first let us try to draw, or let us try to trace the image formed by a concave mirror when the object is placed at infinity. To draw this, first, which is the first case? First case is object placed at infinity, correct? Object placed at infinity. All the 6 cases we are going to learn how to draw the ray diagrams with perfection, with measurement. After learning the drawing of ray diagrams, then we will go how to draw or how to take the ray diagram image characteristics from the ray diagram. Okay, so first step is to draw a straight line of length 10 centimeters. See, from here to here 10 centimeters, and exactly at 5 centimeters you mark a point like this. Okay, so this 5 centimeter point is going to be our focus, and this side point is going to be our pole, and this left side point is going to be our center of curvature. Okay, so now you take a compass of radius 10 centimeters. Keep the needle on center of curvature and draw a curve like this. Don't draw too lengthy curve. This much will be sufficient. Okay, right. And after drawing this, you must draw these small lines. These small lines are very important because these lines are only going to represent which is the polished surface, which is the not polished surface. Okay, so now object is placed at infinity. When object is placed at infinity, what happens? The light rays coming from the object will be parallel to principal axis, correct? So I am going to take light rays parallel to principal axis. When as object is placed at infinity and infinity is imaginary, we have to start the incident light rays with dotted, and then we have to thicken the light rays. See how I have started? I will start with the dotted light rays, afterwards a thick light rays. Okay na? So now here also I will take one more light ray. Okay, so now you can write here object at infinity. Object at infinity. Light rays are coming in this direction. Arrow marks are very important. So now, just now we learnt that when light rays come parallel to principal axis, what happens? After reflection, the reflected light ray will pass through focus, correct? So this reflected light ray will pass through the focus like this. Okay, and this reflected light ray will pass through focus like this. Okay na? So now the point where the two or more reflected light rays will meet, that point will take it as an image. So this point which is present here, this is our image I. Okay na? So now what is the height of the image here? Height of the image is negligible, correct? Are these two light rays meeting or not? See, This is one reflected light ray, another reflected light ray, another reflected light ray. All are meeting at this point. So as they are originally meeting, image will be a real image. Let us write the characteristics of image now. Characteristics of image. First characteristic, image will be a real image. First one, image will be a real image, and all real images are inverted images. Real image and inverted image. Okay, and is the image magnified or diminished? Image is highly diminished. What is this highly diminished or diminished? Highly diminished means height of image will be very less, negligible. Diminished means height of image will be lesser than height of the object. Now, where is the image formed? Image is formed at focus. Okay, na? These are the characteristics of image. How many positions do we have to place object? First we will place object at infinity. Afterwards we will take object closer to mirror. When we take closer to mirror, next position will be behind C, here. And as we take still closer, next position will be upon C. Still closer you take, next position between C and F. Still closer you take on F. Still closer you take between F and P. These are the positions of the image. So first position over, object at infinity. Over, no? So when object is at infinity, image is formed to focus. A highly diminished image will be formed. Image will be real and inverted image. Okay, na? This position over. So now next let us take the next position, object beyond C. Okay, na? So next position, object beyond C. So here also I did the same thing. First I have taken the straight line of length 10 centimeters. You can verify length 10 centimeters, and exactly at 5 centimeters I have marked the focus, and afterwards I have marked that curve taking that concave mirror. Okay, na? Now let us draw the ray diagram. This is the object, correct? See the height of the object. Height of the object is, you can verify, it is 2 centimeters, correct? This is the point from where the light ray should start. We have learned 4 cases, correct? We can take any 2 cases. I'll take one light ray parallel to principal axis. See, I have taken one light ray parallel to principal axis. If I take one light ray parallel to principal axis, yes, this is parallel. After reflection, how the light ray should go? After reflection, the reflected light ray should go through focus. This is the incident light ray, and after reflection, the reflected light ray should go through focus. Correct? Correct, sir. Yes, sir. One more light ray we want. We want minimum 2 light rays. Correct? One light ray. One more light ray we can take through pole also, through center of curvature also, or through focus also. I will take one more light ray through focus. Okay, na? This point and this point. Light ray starting from here and passing through the focus. See? So when light ray comes parallel to principal axis, it passes through focus. When light ray passes through focus, after reflection, it will pass parallel to principal axis, correct? See, now see, this is parallel to principal axis. So reflected light ray passing parallel to principal axis. See, this is one reflected light ray, this is another reflected light ray. This is the point of intersection, correct? So this one will be the image I. Let us find out the height of the image now. See, you can verify in front of you only I have drawn. Height of image is 1.4 or 1.3 centimeters. Correct? What is height of object here? Height of object is 2 centimeters. Height of image, we have got only 1.3 centimeters. Yes or no? So now we can say that height of image is lesser than the height of the object. When the height of image is lesser than height of the object, we say it as diminished image. We say it as a diminished image. See, now let us write the characteristics of image now. Characteristics of image. Is the image real or virtual? Real image. Why? Because the two reflected light rays, this is one reflected light ray, this is another reflected light ray. These two reflected light rays are originally meeting here. We are not imagining that they are meeting there. They are originally meeting. So the image will be real and inverted. Real and inverted. Second point. Where is image formed? See, here image is formed. Correct? So image position means image point. Is this between C and F or not? Between C and F means not exactly between C and F, but somewhere in between C and F. Correct? No. So image is formed between center of curvature and focus. And third point, is the image magnified or diminished? It is diminished. Image is diminished. Correct or not? We got height of image is equal to 1.3 centimeter and height of object we have taken as 2 centimeter. Height of image is minus 1.3 centimeters. Height of object is 2 centimeters. So image is diminished image or not? Image will be a diminished image. So next position is object placed at C. So first object at infinity over, now object beyond C over, now object exactly at C let us take now. Okay now. See, object exactly at C. See now. So this is the object. Let us take one light ray parallel to principal axis. This is the case where the diagram will not come perfectly so many times. See, let us take one light ray parallel to principal axis first now. One light ray parallel to principal axis. After reflection, the reflected light ray should pass through the focus, correct? From here through focus. Over. One more light ray we want, correct? We can take that one more light ray through pole, or we can also take that one more light ray through focus also. I will take that one more light ray through focus. Okay now, like this, through focus. After reflection, how this also should pass? This should pass parallel to principal axis, correct? See, approximately parallel to principal axis. Yes, now this is very close and parallel to principal axis. So you know, this is one more incident light ray and this is the reflected light ray. So this point, if you look at, this is very close to the center of curvature. Yes or no? See. And let us find out the height of the object. What is height of object here? 2 centimeters, correct? Verify the height of the image now. Height of the image, how much it is there? See, in front of you only I have drawn the ray diagram. I have measured the height of the object, how much it is there. You can see it is 2 centimeters. And measure the height of the image also, you can verify it is 2 centimeters. Yes or no? So what did we get? What did we get? Now let us write down the characteristics of image now. What are the characteristics of image? Is these two reflected light rays originally meeting or not? If they are originally meeting, Image will be real and inverted image. What is the position? Where is the image formed? Image is also formed at center of curvature. What is the height of the image? Height of image is same as height of object. Height of image is same as height of object. Okay. Next position where it will be, object will be placed between C and F. When we place object between C and F, image where it will be formed, image will be formed beyond C. See, now let us take next position. See, for each ray diagram, you should take first a straight line of length 10 centimeters, and exactly at 5 centimeters you have to mark the focus, and with taking a compass you should draw a curve of approximately 5 centimeters length. Okay na? After doing all those things, then you have to take the object. Now let us take the object between C and F. Take one light ray parallel to principal axis. See, one light ray parallel to principal axis. After reflection, how the reflected light ray should pass? It should pass through the focus, correct? So now it is passing through the focus. Right? One more light ray we want. One more light ray, which one shall we take? Shall we take through focus? If we take through focus, what happens? We need to extend the light ray. Okay, we can extend it a bit. I extended the mirror a bit. So one more light ray I'll take through focus, and after reflection, how it should pass? It should pass parallel to principal axis. See, it is parallel to principal axis. Now after reflection, as it passes parallel to principal axis, the two reflected light rays, this is one reflected light ray and this is another reflected light ray. This is reflected light ray. Light rays passing through the mirror are incident light rays. Light rays passing away from the mirror are reflected light rays. This one reflected light ray, this is another reflected light ray. Where these two met, they both met here, correct? So this is the point of intersection of the reflected light rays, and this one will be the height of the image. Now you measure the height of the object and height of the image. What is the height of the object here? You can see it is 2 centimeters. What is height of image here? 3.5 centimeters, right? So height of image is greater than the height of the object. So this case we say it as magnified. This case we say it as magnified. So now let us write the characteristics of image. Characteristics of image. First characteristics, image is real and inverted. Why? Because the reflected light rays are originally meeting. Second characteristics, image is formed beyond C, and image is magnified. Real and inverted, formed beyond C, and image is magnified. So between C and F also over. Now next position will be object at F. So now let us take the object at focus. Now here also the same case. We need two light rays to form an image, correct? So take one light ray parallel to principal axis. Yeah, one light ray parallel to principal axis. After reflection, how it should pass? It should pass through the focus. From here through focus it should pass like this. Correct? One more light ray we want. We can take one more light ray through center of curvature like this. Through center of curvature we can take. It is not possible, so let us just extend the mirror. So this is the object. See, now if you observe, from center of curvature light rays will not start. It is appearing as if it is passing from center of curvature, but the incident light ray will start from the object like this. Okay, so this is the incident light ray. Observe neatly, incident light ray went like this, reflected and going back like this. Understood or not? This is not there while incident light ray. Incident light ray came like this. There it reflected back and it is going back like this. Okay, na? So now this is one reflected light ray. This is another reflected light ray. These two are parallel to each other. When we have two parallel lines where they will meet, we imagine that they meet at infinity. Two parallel lines, we imagine that they meet at infinity. So these two parallel lines are going to meet at infinity. That's why where they meet, that is only image. Correct? So image is formed at infinity. Image is formed at infinity. If the image is formed at infinity, then image height where it will be? See, these two lines reflected joined here. Then this one will be height of the image. These two lines joined here. Okay, this one will be height of the image. Now where they are going to join? They are going to join somewhere here, infinitely. Here, somewhere infinity they are going to join. What will be height of the image from principal axis to the infinity point? Infinity, no? That's why we say the height of the image here as infinitely high or highly magnified. Highly magnified. So let us draw the image characteristics now from the diagram. Image characteristics. First point, image will be real and inverted. And second point, image is formed at infinity. Image is formed at infinity and image is highly magnified. Image is highly magnified. We say it as infinitely large also. Highly magnified or infinitely large also we can say. Okay. Now at F also over. Now next remaining cases between F and P. So now let us take the object placed between F and P. Here we should be very careful. What is that precaution we need to take while drawing this ray diagram is you have to take the object closer to pole. Sir, between F and P, this is focus and this is pole. Wherever I want, I will take, sir. Why should I take closer to pole? You can take anywhere. I have no problem. But if you take object closer to focus, image formed this side will go far away. If you take object closer to pole, image formed on the other side, it will be very close. You will understand now. While we draw the ray diagram, you will understand. So now let us take for this one also one light ray parallel to principal axis. After reflection, the reflected light ray should pass through the focus. See, reflected light ray passing through the focus. One more light ray we want. Which light ray shall we take? Shall we take through center of curvature? Let us try first of all. Is it possible or not? Yes, it is possible to take to center of curvature. Correct? So now I am going to take from here also. You see, I am going to start light ray from here, but not from here, but it is looking like it is passing through center of curvature. So incident light ray passing through center of curvature like this, and after reflection it will pass back in the same direction through center of curvature like this. Now if you look at, this is one reflected light ray and this is another reflected light ray. Are they going to meet anywhere? They will not meet anywhere. Why? Because these two are diverging in nature. You can see here distance is less, and as they are moving far away they are diverging in nature. When they are diverging in nature, they will never meet. Parallel light rays, we imagine that they meet at infinity, but diverging light rays, they will never meet. As they never meet at any point, we are going to extend the light rays back. If we extend the light rays back, then we can get a point where those two light rays will meet. See, we got a point that they both look like, they both pretend as if they started from that point. Yes or no? They are not starting from that point originally, but they look like they are starting from that point. Correct or no? That's why we say it as virtual image. These two reflected light rays, they will never meet anywhere. But we extended them back and we are imagining that they are starting from that point. That's why as we are imagining, we say that this is a virtual image. This is a virtual image. Now let us try to write the characteristics of the image. Okay, characteristics of image. Characteristics of image. First one, image will be virtual and erect. Erect means what? This will be at the top, this will be at bottom. Inverted means what? You can see all the ray diagrams which we have drawn. See, this is at bottom, this is at the top. See this image, this is at bottom, this is at top. Means head, tail. Head of the image is at the top, tail of the image is at the bottom, it is erect image. Head of the image is at bottom, tail is at the top, this will be a inverted image. Okay, so now if you see here, this is an erect image. And where is image formed? Formed on the other side of the mirror. Formed on the other side of mirror. It is magnified. Let us see height of the object. See height of the object, how much it is? 2 centimeters. Height of the image, see how much it is? Around 3 centimeters. Correct? So it is virtual, erect and magnified image, and image is formed on the other side of the mirror. Okay na? So this is about the concave mirror image formation. Now let us take convex mirror image formation. How many cases do we have for convex mirror? We have only 2 cases for convex mirror. What are those? Object placed at infinity and object placed somewhere between infinity and pole. Okay na? First let us take object placed at infinity. Object placed at infinity. For this one also, first take a straight line. First take a straight line of length 10 centimeters from here to here, 10 centimeters, and exactly at 5 centimeters you mark a point. This one will be the focus, this one will be center of curvature. No, this one will be pole. Before it was pole, it was center of curvature. Now we have to change it. Why? Because we have to draw from this side to this side now. Okay, and the small lines which we have drawn for the concave mirror and for convex mirror, these should be on the opposite side now, like this. Okay, now object is placed at infinity. Object is placed at infinity means light rays will be coming from infinity and the two parallel to principal axis, correct? So take light rays parallel to principal axis above the principal axis and also below the principal axis, like this. See? So light rays are coming parallel to principal axis. How after reflection they have to pass? After reflection they have to pass or they have to appear as if they are passing through the focus. Correct? So from focus they have to pass like this. And here also from focus they have to pass like this. Okay, so this point is the intersection point of the reflected light rays, because see these two are again diverging light rays, they are never going to meet at any point. That's why we extend those reflected light rays back and we imagine that they started from that point. The point where the reflected light rays will meet, it is going to be our image. And where is the height of the image here? There is no height only for image. Height of image is only approximately equal to 0, right? So let us find out the characteristics of image now. Characteristics of image. It is going to be virtual and erect. Correct? And the second, where is it formed? It is formed at focus. And what about the magnification? Image is going to be highly diminished image. Highly diminished image. Okay. Now as we have got pole, focus, center of curvature on the opposite side of the mirror, object will be placed on the other side of the mirror. We don't have pole, focus, center of curvature in front of the mirror, in front of the reflecting surface. That's why we have only two positions for the object to be placed in case of a convex mirror. So first case will be like this, object at infinity, and the second case will be object between infinity and pole. Okay, somewhere here in between infinity and pole, somewhere we place an object. Okay now, so for this case how to draw? First take a light ray parallel to principal axis. After reflection, how it have to pass? It have to pass through the focus like this. Correct? Like this. Okay, one light ray. One more light ray we want. Which light ray shall we take? We can take from center of curvature to object. It is possible. Yes, it is possible. Let's see. Now observe the diagram what I am drawing neatly first, because students will get confused. So now from here one light ray came like this. Okay na? It came until here. Can it come until here? It cannot come until here. It came like this and it is appearing that it is passing through center of curvature, and as the light ray passes through center of curvature, angle of incidence will be is equal to 0. So angle of reflection also will be is equal to 0. So it will go back like this. So light ray came like this and it will get back like this. Correct? That light ray only we are extending here. See, this is the point of intersection. Light ray came like this and reflected light ray went like this. Are you understanding my point or not? Right? So now this is one reflected light ray, and here two light rays are present. Incident light ray is also present here only. Reflected light ray is also present here only. So incident light ray came passing through center of curvature. Angle of incidence is equal to 0. So angle of reflection is also equal to 0. So it went back like this. Correct? So this is the point where the two reflected light rays met, and this one will be our image. This one will be our image. Okay na? So now measure the height of the object. The height of the object will be 2 centimeters. Where is the height of the image? See, it is 1 centimeter. You can see here, height of the image is 1 centimeter, and height of the object is 2 centimeters. Understood or not? So now let us write the image characteristics. What will be the image characteristics now? Image characteristics. First one, image is virtual and erect. Virtual and erect. Where is the image formed? Image is formed between P and F. See, P and F, between P and F. And is the image magnified or diminished? It is diminished. And if you take object to closer, image will also come closer. If you take object to farther, image will also move farther from the mirror. Okay, this is about the image formation of concave and convex mirror with measurements, how to draw. Now I hope you understood all the ray diagrams, and in the next video I am going to solve problems on concave mirror. Thank you. Keep studying. All the best.